And next one we have an LDR. So LDR is a light dependent resistor. So LDR is it's also called as a photoresistor, or it is also called as a photoconductive cell or a photodetector. So it is a two-terminal device which is commonly coming under a name called as LDR, light dependent resistor. So as you know, the name indicates the resistance of this device depends on light. So how much light I am going to focus on the device, that much amount of resistance I will be getting. So I am going to use those materials which are sensitive to light. So you can see these devices are made up of materials like cadmium sulfide, CDS, lead sulfide, or cadmium selenide, whose spectral response is shown below. See the spectral response. You have a maximum response of cadmium sulfide at 0.6 nanometers. 0.6 micrometers. You have a maximum response for cadmium selenide at 0.75 micrometers. So because of this good property of these devices, cadmium sulfide and cadmium selenide, I am going to use these devices as a material for light dependent resistor. So you have a lot of applications of this photoconductive cell because it has high dissipation capability with excellent sensitivity in the visible spectrum. So when you're going to focus light, it is going to turn on and produce the resistance. So it is going to have a very good sensitivity. Sensitivity means how it is responding to light quickly. That is going to be the sensitivity. So they have say it has high dissipation capability, very excellent sensitivity in the visible spectrum. So even if you show visible light on the device, you can expect the device to be turning on. So you have two cells. You have CDS cell, and the one drawback of CDS cell is it is slower in response, but lead sulfide is fastest in response. So among the candidates for LDR, the one which is going to have a quicker response is going to be lead sulfide cell. Okay, the illumination characteristics are given. It exhibits the peculiar property that its resistance decreases in the presence of light and increases in the absence of light. So it is just like the resistance is inverse. As the light is going to be more and more focused, the resistance is going to be less. As the environment is more and more dark, the resistance is going to be high. It is inversely proportional. Okay. So how I am going to use my LDR in a circuit? In a normal circuit, along with the resistance, you can have that photoconductive cell or LDR also, and you can illuminate that with light. So you can see as the illumination is less, the resistance value is high. As you increase the illumination, the resistance value sharply decreases from 100 kilo ohms to 1 kilo ohms. So this can be used as a variable resistance unit in any circuits where the resistance value has to be changed. By applying a controlled amount of light over this LDR, I can control the resistance of the device. So this is going to simply act like a conductor whose resistance changes when you are going to illuminate it with visible light. In absolute darkness, you can see the resistance value is very high as 2 mega ohm, and in strong light, the resistance is as less as 10 ohms. So 2 mega ohm in darkness, I can consider it to be open circuit. When I'm going to illuminate the device with the light, the resistance is 10 ohms. 10 ohms means I can call it as a short circuit. The simple circuit for photodetector is shown here. This diagram what we have seen. So I can, if I change the voltage, if I can change the light intensity, and if I plot a graph, I get this graph. So as I am going to increase the intensity of light, the resistance value is going to drop abruptly. There is going to be a sharp variation in the resistance value of the LDR. So a glass window in the housing permits the light to fall on the active material of the cell. So here the resistance of photodetector is in series with the resistance R, which will limit the amount of current. So ammeter will measure the current flowing through the device. When no light falls on the cell, the resistance is very high and the current is low. So it is just like when automatic lighting. So you can keep this on top of your you can keep this device on top of your house, and when it is going to detect the light, you can switch off the light inside the house because the room is already bright. When it is going to be in the evening or night, when there is no light, this circuit will detect that by change in resistance, and you can turn on the lights inside your house automatically. So it is just like how we are going to play with the light. Since this device is working, and the working of the device is purely based on light which is incident on the device. Depending on whether how much amount of light is incident, I can either increase or decrease the resistance of the device so that I can be using it for appropriate application. One simple application what I told you is the simple application of your house where you can use it for automatic lighting. So the voltage across the resistance is very low. So when the cell is illuminated, the resistance become very low. So the current will increase. So in normal condition, when there is no light, the resistance is very high and the current is less. When the cell is illuminated with light, the resistance is very low and the current is going to increase. So you can change the circuit in accordance with whatever application perspective you have. So this can be used. This device can be used to detect presence or absence of light by using an on-off. As like an on-off with automatic street lighting, you can use it because when the sun is going to set, when there is absence of light, these street lights should be automatically turned on. In the morning, when there is sufficient amount of light, these street lights can be automatically turned off. So this is just like a simple control application where you can use this LDRs to simple applications like turn on or turn off your device. Or it is also used to depending on the response, you can trigger some relays or motors, or you can it can also measure the illumination. So depending on what is the resistance value you have, you can measure how much light is illuminated on the device. You can, because resistance is proportional to the amount of light, right? So you can easily measure how much amount of illumination is falling on the light dependent resistor. So it is also used in counting systems. In conveyor belts in airport where you have baggages, right? So you can count the number of baggages using this LDR. And it is also used in twilight switching systems in CCTV cameras. Also, you can have it whenever you can see in CCTV cameras when they are operating in daytime, no light is emitted. In night time, you have a red light emitted from those cameras, right, for capturing the night images. So that light can be detected based on the LDR. So as you see that when there is absence of light, these LDRs can be used to detect that, and automatically the red light inside the CCTV cameras can be turned on in the evening and night. So it is just like I'm going to automatically switch on and switch off my light. It is widely used in cameras to control shutter opening during flash. The main application of LDRs is you are going to control the amount of shutter opening when you are going to take pictures using flash. So the control twin PC cells are placed in the same circuit, and by proper controlling and other mechanism, you can achieve this property in your digital cameras, where the shutter opening and closing is controlled by this amount of light during the flash. So this completes our Unit 4.